For question 1, we're going to graph a system of equations to solve. And so we're going to use that format of y equals mx plus b, where m is our slope and b is our y-intercept. So when we look at this equation, it is in slope-intercept form, starts with y equals. So we see that our slope is -3, which remember we can write as a fraction of -3/1, if that helps us graph. Our y-intercept of b is that last value at the end, +6, and that's where we start on the y-axis. And so we can graph our y-intercept on the y-axis here, and then use our slope to find more points on our graph. So when you're at the y-axis, using your slope of -3/1, you can go down 3 units and to the right 1 unit. Remember, you can also go up 3 units and to the left 1 unit. And when we're graphing on here, it'd be good to show multiple points since we're looking where the two lines will intersect. So I will show more points here and then draw a line. So line 1 is ready. I see multiple points shown on the line. Chances are if I have a solution to this problem, it'll show up at one of these points. For our second line, we see the equation is not in slope-intercept form. So we can fix that. We've practiced that multiple times here. To get y by itself, one thing we need to do is have our x on the opposite side of the equation. So we can add 4x here to cancel with the -4x. And that will give us 2y equals 4x. And since that's a +2, we'll put +2. Remember, you can't add these together because the 4 has a variable x and 2 does not have a variable. And then last thing, when we divide by 2, that means that we divide the entire right side by 2, meaning we divide all values on the right side by 2. And so we get y equals 4 divided by 2 is 2, so we have 2x there. And then 2 divided by 2 gives us +1 here. And just like before, our slope is the coefficient with x, so we have 2, which remember we can write as 2/1, and our y-intercept is +1. Okay, so we will start at, we'll put a point of 1 on the y-axis, since that is our y-intercept, and slope of 2 means to go up 2 and over to the right 1. And so we can either go up 2 or to the right 1, which you notice is where we're going to cross the other line. So we could be done there, but if we wanted to be a little more technical, we could do that multiple times. We could also go in the other direction, go down 2 and to the left 1. So we'll show some points and we will graph that line as well. And now that we have both lines graphed on the same grid, we see where they intersect, and that will be our solution, which in this case appears to be at 1, 3. Okay, so there's number 1. For question 2, similar question here. We have slope-intercept form, y equals 2/3 x minus 5. So our slope is 2/3, which is already in fraction form, and our y-intercept is at -5. And so if we show our y-intercept at -5, and then use our slope of 2/3, that's a positive slope, so the line should increase. We can either go up 2 units and to the right 3 units, or we can go down 2 units and to the left 3 units. Either way, you notice the dots are lining up. Okay, and since we're trying to figure out where two lines will intersect, it's good to show multiple points. So I'll show those points and then I'll draw through them. So there's our first line. Going for our second line here, we need to have slope-intercept form to use the same strategy. So to get y by itself here, x is already on the opposite side, so we can skip that step, but we do need to cancel the 3, and we cancel any coefficient like this by dividing. So when you divide both sides by 3, you get y equals 2/3 x. And there is no y-intercept shown at the end. Remember, in those cases, you can show it as 0. So we can say the slope of this line is 2/3, and the y-intercept is 0. Now, maybe you remember what happens when two lines have the same slope and different y-intercepts. If not, we can graph. Graphing the y-intercept of 0 and Our slope is 2/3, which would tell us to go up 2 units and over 3 units, and continue that trend. We can also go down 2 units and to the left 3. And you might notice that with these dots, after I draw the line, that these lines will not intersect because they are parallel. If you recall, parallel lines have the same slope and different y-intercepts, and so if they do not intersect each other, there is no solution. And that is all for question 2. When we get to question 3, you might notice we have the option to use either substitution or elimination to solve. We have our choice, but also remember there are strategies when to use which. So substitution was those cases where you have a variable by itself. We see a couple cases of that. Question 4, for example, has y by itself. Question 3 has a couple options with x by itself. So we can use substitution here. Remember, elimination is when everything is lined up in your equations. So we see down below, question 6 will have the x's lined up, the y's lined up, the equal signs lined up, as well as the constant values without a variable. Technically, so does 3. The x's are first, followed by equal signs, followed by y's, and followed by these last values. So we could use elimination here. If you do that, you'll end up getting a 0 on this side when you cancel the x's. But it is set up for substitution as well because we do have x by itself. So when I look at number 3, I like to think of this one as substitution. So I'm going to show it like that, where we have x equals 4y plus 5, and the other equation is x equals 3y minus 2. Okay, and so what we say is if you have a variable by itself, so if x is equal to 4y plus 5, that means those two things can interchange. And so anywhere we have an x, we could replace it with this expression 4y plus 5, which is what I'll do over here. You notice have the letter x again. The green equation tells me that x can be replaced with 4y plus 5, meaning I can come over here and replace this red x with that expression 4y plus 5, and the rest of the equation will stay the same. Pretty simple way to do this. So hopefully you see I'm just taking this green expression that we know x is equal to and using it for our x over here. Now to solve the equation, we do need to solve for y. We need to cancel one of these y's since they're on opposite sides of the equation. So we could cancel the 3 y's, for example, by subtracting. That would leave you with 1y over here. But remember, 1y is the same as y. Okay, still have a plus 5 and still equal to negative 2. Okay, one last step here. Subtract 5 to get y by itself, and you can check in a calculator if you need to. These will cancel, and negative 2 minus 5 should be negative 7. And now that we have our y value, we can use that to go to substitute anywhere we have the letter y. So now we know that anywhere we have the letter y, its value should be negative 7 in our solution. So I'm going to change that equation to red so you can see where this is coming from, but we do know y is equal to negative 7, so when we come up to this other equation where we had x equals 4 times y, we can now replace that y with a value of negative 7. So we have x equals 4 times negative 7 plus 5. So you can see I'm not changing anything else. All I did was I instead of using the letter y again, I put in a value for it. Now after that, what do we get? We have x equals, this is going to be negative 28 plus 5. And you add those together, you get x equals negative 23. And those should be the values of our solution, not something that we would be likely to see on a graph where we normally would graph it. So it's good to have another strategy to find this answer. Okay, so for question 4, looking at it, we see that substitution is a good idea because the first equation has y by itself. And we saw in number 3, it doesn't have to be y that's by itself. It's okay if it's x. It just needs to be one of the equations or the other, or both. As long as you have at least one, it's set. So we do have that one. We have a y by itself here, and that allows us to substitute. So over in our second equation, what we're going to do, just like we did in number 3, is where we have the letter y, we're going to replace it. So I still have 4x plus 3, but instead of using the y again, this first equation says y is equal to 2x plus 2. So y can be replaced with that expression of 2x plus 2. And that's all I've done there. Okay, you notice everything else in the equation is exactly the same. Still have 4x, still have plus 3, still have equals 16. Just replace the y. So there's no longer a y in this equation. I keep solving. I have 4x, and we have to distribute this 3. So we'll take 3 times 2x. That gives us 6x. And 3 times 2 would give us plus 6 equals 16. Combining like terms, because these x's are on the same side of the equation, 4x plus 6x is 10x. And then we have plus 6 equals 16. And then we can subtract 6 on both sides of the equation. That way we have 10x equals 10. And lastly here, if we divide by 10 on each side, we get x equals 1. And again, now that we have a value for x, we can use that wherever we need to. So anywhere we have the letter x, we can replace it with this value of positive 1. And so if we go to our first equation in green here, it says y equals 2 times x plus 2, but we can replace that x value now, that x, with a value of positive 1. So instead of 2 times x, we have 2 times 1 plus 2, and that gives us y equals 2 plus 2. So y equals 4, and let's keep track of our variables. We said x is 1 and y is 4. And that should finish this question for us. Okay, in question 5, you should see that the equations are set up for elimination because everything is lined up. The x's line up, the y's line up, the equal signs, and the values at the end. We look at it and we see what variable is likely to cancel, or what one do we want to cancel. And you might notice in number 5, it's set up for you to where the y's will cancel, because anytime you have a positive and a negative of the same value, so in this case positive 15 and negative 15, they will cancel. And so we're ready to cross those out if we add. So if we add these equations together, the y's will cancel away. You take negative 2x plus 21x, which is 19x. The y's will cancel, and we're still adding here. That's what happens when you combine equations. You are adding them together. And so we take negative 32 plus 51, which is nice, comes out to 19. Okay, and then we solve this equation here pretty quickly. It's the beauty of elimination. It's how quickly things go after you cancel a variable. In this case, we just need to divide by 19 on each side, and x is equal to 1. Okay, and you notice that's not going to finish the question for us because the system has multiple parts to its solution. So we have x, now we need y, but it's a similar strategy to what it was before. Now that you know x is 1, you can use that anywhere you have it. So you notice in these first two equations, they both have a letter x. We can pick one of them. So let's say we pick that first equation. We can replace that variable x with what we just found, so positive 1. So we can take negative 2 times 1 instead of negative 2 times x now. Negative 2 times 1 plus 15y equals negative 32, which is going to help us solve for our second variable. So simplifying here, when you multiply negative 2 and 1, you just get negative 2 plus 15y equals negative 32. add 2 to both sides, and we get 15y equals negative 30. Divide by 15, and y equals negative 2. And that is the conclusion of number 5. For number 6, somewhat similar. Everything is lined up for elimination. We have our x's followed by y's, followed by the equals, followed by those constant values. And we get hasty here sometimes, and we think, oh, something cancels already. And we're not quite there. We do notice that the y's are very similar, but they're both positive. And because of that, they won't cancel. But we can fix this issue, right, through multiplication. And one value that's easy to multiply by, if that's all you need, is a negative 1. And so let's say we multiply the second equation by negative 1. That means I'm going to multiply every value in that equation by negative 1, which really just changes the signs of each value. So when I multiply by negative 1 to 2x, I end up with a negative 2x. Negative 1 times positive y is now a negative y equals, and then negative 1 times positive 10 is now negative 10, which is good to have, because if we take that equation and compare it to this equation, 3x plus y equals 5. I'm going to change the color there so it wouldn't blend in with the problem above it. But if I bring this equation over and don't change it in any way, we notice it works out very nicely for us, because when I add these together, those y's are opposites. So positive y plus negative y cancels away, which is exactly what we want with elimination. So if we continue here, we have 3x plus negative 2x. That is 1x, which is the same as just putting x. The y's will cancel away. And then we have equals 5 plus negative 10 is negative 5. And just like that, we already have part of our answer. Now all we have to do is use it to find the other. And so if x is equal to negative 5, we can use that in any equation that we have utilizing the variable x. So let's say we just go back to that first equation that says 3x plus y equals 5. Well, what does that tell us? It means that we can use our new x value that we just found. So switch out x with this value of negative 5, and now the equation would say 3 times negative 5 plus y equals 5, which will give us negative 15 plus y equals 5. Add 15 on both sides, and y is equal to 20. And that is it for number 6. For number 7, we see still a setup for elimination. The x's are lined up, the y's are lined up, the equal signs, and those constant values. But nothing cancels yet. So we compare. We have a 3 and a 5, so those aren't matching here. We have a 4 and a 2 in front of the y's. Those aren't quite matching yet either. And we know what values cancel are values like negative 8 and positive 8, or 15 and negative 15. So we need combinations like this. So when we don't have those, we can create them through multiplication. And so we can choose what's going to be simpler here. Do we want to cancel the x's? Do we want to cancel the y's? And there's no wrong answer. In this scenario, I would focus on the y's, because I know that 2 goes into 4. And so I don't have to change the top equation if I pay attention to that. So if I take this top equation and leave it the exact same, don't change a single thing about it, we get 3x plus 4y equals 6. For the second equation, though, I'm thinking, what do I need to cancel with positive 4y? That would be a negative 4y. So what is it I need to multiply by to get a negative 4y in the middle here? Obviously, we're going to need a 2, because 2 times 2 is 4. but 2 times this positive 2 will give us a positive 4. But if I change this to a negative 2, all that's going to do is just give me the opposite sign with the 4. So I'm going to multiply by negative 2 here. Watch with me, and maybe you'll see. Because when I take negative 2 times 5x, I get negative 10x. When I take negative 2 times 2y, I get negative 4y. And when I take negative 2 times negative 4, we get equals positive 8. And that right there creates two opposite values for when we combine, they will cancel. So 3x plus negative 10x is negative 7x, and 4y plus negative 4y does cancel away. And we get over here 6 plus 8 is 14. It's all working out pretty smoothly. We divide by negative 7 to get x on its own, and we find out that x equals negative 2. Okay, and the same story over and over again. So far this assignment, to solve for y, all we have to do is substitute our x value into an equation. So let's use this negative 2 somewhere. If we take that first equation that says 3x plus 4y equals 6, we can replace the x with a negative 2 and solve from there. So this would be 3 times negative 2 plus 4y equals 6. That'll be negative 6 plus 4y equals 6. If we add 6 to both sides, 4y is equal to 12. Divide by 4, and y is equal to 3. And so we find our solution is at negative 2, 3. Okay, so for number 8, if we look at this one, we want to solve here and asking ourselves what variable might be easy to cancel. So we see the x's have coefficients of 10 and 5. Those might work well together. The y's have coefficients of 14 and 7. Those might also work fairly well. So no wrong answer here. Let's say you want to cancel the x's. Well, we don't have a lot of work to do because the first equation has a 10 in front of the x. The second one has a 5, but 5 goes into 10. So we could multiply to change this to say some kind of 10. So it seems like we should be able to leave the first equation as is, which would be 10x plus 14y equals 18. And we should be able to do just a little bit of work to change our second equation so that it starts with a negative 10 to cancel with the positive. So once again, think this through. If we use a 2, 2 times 5 is 10, but that's going to be a positive 10, which won't quite cancel. So if we need the negative, we'll put that there. Negative 2 times 5 is going to give us a negative 10, which is exactly what we want. So let's use this negative 2 and see what happens. Negative 2 times 5x is negative 10x. Negative 2 times positive 7y is negative 14y. And then negative 2 times positive 9 is negative 18. If we add these together, we do notice that 10 plus negative 10, these x's cancel away. 14 plus negative 14, the y's will cancel away. And then we have an equal sign. So we have an issue here. We have to put something down. An equation cannot be empty. So if there's nothing left over here, that's because we have a value of 0. So we always have to have something on either side of the equal sign. And then on the right side of the equals, we have 18 plus negative 18, also 0. So you might notice there's no more variable in this scenario. And when we lose our variable, that is time for us to interpret what the solution would be. And because the equation is true, 0 does equal 0, we are going to say that there are infinitely many solutions. And that would mean that there are just many, many, many different solutions that are going to work. It doesn't mean all numbers work, all combinations of numbers work, but there are an infinite number of possibilities to choose from. If we get equations that say a false statement, such as 0 equals 4, that would be a scenario where we would say no solution. Okay, to wrap things up, just a couple applications here. Should be pretty straightforward for us. We've seen this scenario a few times already. It says the sum of two numbers is 16. So we do need to remember that sum would imply addition. And then it says the smaller number is less than 20, is 20 less than the larger number. So we'll get there. We'll get some equations set up. First thing, though, is to figure out what our variables are. And it says in the question at the end, what are the two numbers? Okay, and so that is what we want to know, what these two numbers are. And since they referenced a smaller and a larger number, we will do the same. So let's say x is the smaller number and y is the larger number. Okay, so to write our equations, we just take one sentence at a time. Remember some things, the word is means equals, and so here we see in this first equation when it says is 16 at the end, that would imply to us that our equation will end with equals 16. And then we just need to realize again what that word sum implies for us, and sum is implying that we're adding the two numbers together. So for sum, we will have x plus y equals 16. For the second equation, though, it says the smaller number is. So there's that word is again for our equal sign, okay? So the only things that go before the equal sign will be mentioned right here, the smaller number. And we said just a moment ago that x is our smaller number. So that tells me this equation starts out with x equals. And then it says 20 less than the larger number, which means to take 20 away, to subtract 20 away from the larger number. So we will have y minus 20 for this one. Okay, so we've stated what the variables are. We've shown the two equations that we have information about. And then we have to figure out how to solve this system. And I'm hoping you see that while you're thinking about this, the two equations do have a different setup. The first equation has an x followed by a y, while the second one has an x followed by an equal sign. So this is not set up for elimination because of that, but substitution would be a good idea because you have an equation right here that has x by itself. And because of that, that means anywhere we have the letter x, such as up here, we can replace it with this expression. So if x equals y minus 20, this x also equals y minus 20. So we can switch out. And that's what we're going to do. So let's get ready to do that here with our equations. So we have x plus y equals 16. And we have x equals y minus 20. So let's go ahead and substitute into this red equation. Instead of using the letter x, though, let's replace it with what x equals. So x equals y minus 20. Let me go ahead and replace that here. So instead of using x, I'm replacing it with y minus 20. But everything else stays the same. We still have a plus y, still have equals 16. And then we need to combine like terms. So one y here plus another y here on the same side of the equal sign. 1y plus 1y is 2y. So we get 2y minus 20 equals 16. We can add 20 to both sides. 2y equals 36. And if we divide by 2, we get y equals 18. And if you know what y is equal to, that allows you to go substitute into your other equation. So in this green equation where we have x equals y minus 20, we know that y is going to be equal to 18. So let's go ahead and replace it with 18. And so now we can say that x equals 18 minus 20. And so we figure out that x equals -2. And now we interpret our answer. We said y is the larger number. And so when it says the larger number is, we're looking at y. And we said that is 18. And the smaller number is -2, just as we found for x. Okay, lastly, we're going to look at one more application. Similar to what we've seen on a homework assignment or two. We see a store is having a sale on chocolate chips and walnuts. For 3 pounds of chocolate chips and 5 pounds of walnuts, the cost is $25. For 9 pounds of chocolate chips and 7 pounds of walnuts, the cost is $53. And this is asking us to find the cost for each pound of item. So that would be our variable. It's the unknown value that we are trying to find. So when we talk about x and y, we can talk about chocolate chips and walnuts, but we need to reference what it is we're finding about them. And in this case, we're finding the cost per pound. So we'll put x equals cost per pound of walnuts, or maybe you just put cost of, maybe we'll use chocolate chips. So cost per pound of chocolate chips. And that's just a little more technical way. It's really stating what we're finding. We are figuring out how much they cost. And then we'll do the same for the y's. So the y is going to be cost per pound of walnuts. And now that we have those, we should be ready to start setting up some equations. And remember, just take one sentence at a time. Our first sentence here that references some value says 3 pounds of chocolate chips. So I know that chocolate chips I'm representing with x. So 3 pounds of chocolate chips is going to give us 3x. And 5 pounds of walnuts, well, I'm using y to show the cost per pound of walnuts. So combine 5 pounds of walnuts with this calculation, we'll have plus 5y. And then we said the total cost is meaning equals $25. And then we can do that again for 9 pounds of chocolate chips and 7 pounds of walnuts. So we get 9x plus 7y. The total cost is 53, so we get equals 53. All right. And looking at this setup, we do see that the x's are lined up, the y's are lined up, the equal signs are lined up, and your two constant values are also lined up. This would be a case of elimination when everything works out that way. So let's take these two equations here and let's write them down to where we have some room to work with them. So we have 3x plus 5y equals 25, and we also have 9x plus 7y equals 53. Okay, so for elimination, we're trying to get some things to cancel. We compare our coefficients. Do 3 and 9 work better than maybe 5 and 7? And there's no wrong answer here. We just need to have a positive of a value and a negative of that same value in order to cancel. Now, I like the x's here because I realize that 3 goes into 9. And so I think about that and I realize if I just keep the bottom equation the same, don't change it at all. So 9x plus 7y equals 53. But if we choose to multiply the top equation by not just 3, right, but by -3, because multiply by -3 times that 3x will give us a -9x, just like we need it to say. And so I'll multiply by -3 to get -9x. -3 times 5y is -15y. And lastly, -3 times 25 is -75. And so we have these equations. The x's are going to cancel. We are ready to add. So we add those. They do cancel away. -15 plus 7 is -8y. And -75 plus 53 is -22. And you might get worried for a second. You realize that -8 doesn't go into 22, and that's okay. one, fractions and decimals are always fine, but in general here we're talking about money, and a lot of costs involve cents, dollars and cents. So we're going to be okay here. We divide by -8 and divide by -8. And we end up getting y equals 2.75, meaning $2.75. So totally normal. And now that we have that, we do need to go substitute it in somewhere where we have the letter y. It doesn't matter. If you go back to one of your original equations, such as this green one that says 3x plus 5y equals 25, I can replace the y with what we just found. So I'll have 3x plus 5 times 2.75 equals 25. And from there, all we need to do is multiply. And we get 3x plus 13.75 equals 25. And then we can subtract 13.75 on each side of our equation. And so those will cancel. We have 3x equals 11.25. And so if we divide by 3 and divide by 3, we do end up getting 3.75 for x. In other words, $3.75. And so what we found just there, since x is our cost per pound of chocolate chips, we do see that it costs $3.75 per pound of chocolate chips, while it costs $2.75 per pound of walnuts. And that should be the end of that question.